Alright, in this video we're going to talk about for loops, which is the second of three looping mechanisms I will talk about. For loop you'll normally just use for count control looping. In the last video I showed an example with the while loop where we did a count from 1 to 100 and printed the results to the screen. And that's actually still here. This is exactly the same as the first example from the last video, with a slight difference that I printed the part where we started doing that, and I'm going to uh, print out to the screen when we're starting the for loop. You'll notice that the for loop, the same idea. This little thing that will also go from, actually, it needs to be right there. It will go from 1 to 100, just like this one, but I'm doing it in 2 lines of code. And I'll just go ahead and just cut to the chase and show it to you real quick. Oops. And you see, scroll up here. There's the while loop that went to 100. Then I started the for loop, and it goes from 1 to 100 also. So it makes the count control looping a lot easier. Basically, the syntax for a typical for loop is you'll have the keyword for, whatever variable as you count. Like, with the while loop, you had to set up your variable originally, the variable that you'd print out or do whatever with, and that you would actually keep track of your number of iterations with. In this case, I call the variable count. Well, you can make it with the for loop. You can make that variable just on the fly. You actually just can create it inside of the command to do the for loop, the syntax for that. So it's keyword for some variable name that you want to have these iterations as these iterations are counted, and whatever number of iterations you're currently on, you just make up some variable name. And that's what will get stored in that. Then there's another keyword called in. In my case, I'm using what's called xrange. You can also use a value called just range. Like, there's another version that's just this. I prefer xrange for the sole reason of efficiency. If you're beginning to program, you're not going to worry about efficiency as much, but the longer you do it and the more complicated your programs, the larger they get, the more you will become concerned about efficiency, because you want your program to run correctly, but you also want it to run as fast as possible. So what xrange does, when I say it's more efficient, is xrange only generates the numbers as you're going through this loop between 1 to 100. It generates the numbers as you need them. That way, if you exit the loop early for some reason, you don't waste time generating the rest of the numbers. Whereas just the plain range function will generate all the numbers at once, and that's just less efficient. It's not as big of a deal for a small loop like this, but if you're looping to, like, say, a billion, and there's a good chance that you would actually exit the loop before you got to a billion, and you've done a bunch of number generation that wasn't necessary, and it slows your program down. But anyway, then once again, just like all these other constructs, the if statement, while loop, and all that, they end with a colon, and then you can then over and put the line of code or lines of code that you want to do. So the way that this is working is the xrange works, and the same thing with range, is you'll put in the number you want to start counting at, and you'll put in the number, basically the number after where you want to stop. Because you can kind of think of this, instead of 1 comma 101, you can kind of think of that comma as a less than symbol. So you're saying I want to start at 1 and put that 1 in x, and as long as this value is less than 101, which would be up to 100, continue going through and looping, unless I tell you to exit early for some reason. And that's really the pretty simple as far as the syntax. It's pretty much all there is to it. With xrange, there are actually kind of multiple, not versions, but multiple ways you can deal with this function. It's actually what's called an overloaded function, which we'll get into later, which means that that you can give it a different sets of parameters, which are the values that you put inside of this while loop. On this one, and just to make this easier to read, I'm going to go ahead and take this out, and I'm going to change, instead of going to 101, I'm going to go to 10, just to make it easier to read. So there's what I did here is I gave the value to start at, and then the less than comparison, how far to count as long as it's less than this value. Well, there's actually 2 other ways you can do it. You can actually just give it one value like this, And what it'll do is it'll assume, if you only give it one value, that it assumes that one value is the comparison for the less than, and it will start at 0 and count until it'll keep going as long as it's less than whatever this number is. So to show the example there, it starts at 0 and it goes to 9 because 10 is the last whole number that's less than 9. Or I'm sorry, 9 is the last whole number that's less than 10. And it just assumes a starting point of 0. You can also, we'll just go ahead and do that. You can also give it a third parameter. Your first parameter, if you have one parameter, it's just considered the stopping point. If you have two parameters, it's going to consider your starting point, your stopping point, and your third parameter would be your step, which is how many to go with each iteration. Like right now, every example I've showed you, it goes up by 1. But with this 2 here, I'm saying start at 1 and continue as long as you're less than 10. But each time you loop, go up by 2 instead of 1. So as you see here, it goes 1, 3, 5, 7, 9. It moves up by 2 instead of doing like this one and moving up individually. Now you can also go, if you want to count down, you're actually allowed to do that also with these. Like, I'm going to go ahead and take the step out. If you take the step out, it assumes a count of 1. And I'm going to say, actually, I'll need to put the step back in. I lied. Let's say we'll go from 10. So start at 10. We want to end at 0. And we want to put -1 for the step. Or we're going to count down. If we don't put the -1 in for the step, it assumes counting up. It's going to count up. Then 10 is already greater than 0. So this loop would never actually go. Which I'll just go ahead and give you a case in point and prove that to you. See, nothing happens because 10's already greater than 0. But if you put the step of -1 in there, it kind of smart enough to know to flip things around, and that you're actually wanting to start at 10 and count down as long as you're above 0. So then it gives you 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, which is exactly what you'd expect. And then another important note. I'll tell you about looping. I'll go ahead and mention it now because it'll be probably a few videos before I show the final loop. I'm not actually going to show an example right now, just because I can't think of a great one off the top of my head. So I need to mill on that one a little bit, and I may make like a little 2-minute video to show an example later on, or include it in a later video. But you can actually nest these loops. What that means is you can have a loop that contains another loop. Loopception, basically. So I could have this for loop, say for x and range that, and I could, turn around and say for y and x range, and I'm not gonna actually type the code out all of it, but x range and yada yada yada, the stuff goes in there. And then you could have, your code inside of this loop, and then what would happen is. And I'll show an actual example of this later when I think of a good one. That's the problem I run into. I can think of examples, but a lot of the examples I think of, are things that I've seen as homework when I was taking these classes as an undergraduate. And I don't want to post problems like that because I don't want to give people that are looking for an easy out. I don't want to do your homework for you by accident, basically. So I'll have to think of an example. But anyway, the way this would work is this thing, if this was true or this was still good to go, it would loop, immediately hit here, and then this thing would loop until it was done. It'd loop back up, and then if it still had another way to go, if it still was good to go, it would come back to this one and loop however many times. So the way to think of it now, and like I said, it'll be easier to wrap your hand around when I show an example later, is as long as both of these are true, for every one time this thing is true, this for loop will run its entire iteration. Like however many, so if this thing is supposed to run 10 times, and this loop is set up for 10 times, then every one time this is true, this thing would run 10 times. So you would wind up getting, 100 runs out of that. But anyway, maybe I should have waited and just showed an example with that one. But, I'll show one in a future video.